the channel. How are you all? I hope you are all fine. In this video I am going to explain 10th class maths state syllabus chapter 2 sets. Okay, previous video already we completed types of sets. Okay, now in this video I am going to explain operations on sets. Operations on sets. What are those operations? Okay, on the sets we should do the operations. What are those operations? Let me explain. Okay, actually generally on if you take normal numbers, on normal numbers we can do the operations, arithmetic operations. Yes or no? What are the fundamental arithmetic operations? That basic fundamental operations are addition, subtraction, multiplication and division. Yes or no? These are four fundamental operations. Where we should use these operations? We should use these fundamental operations are numbers. Yes or no? Suppose numbers 2 plus 5, 7 means this addition we are using on the numbers, right? Suppose 5 minus 3, 2. Suppose 10 divided by 5. Okay. So like this, suppose 2 into 3, 6. Okay, 2, quotient 2 if you divide this 2. Okay, like this we should use these fundamental operations on numbers. Yes or no? Now on the sets, what type of operations we can use, let us see. Okay, here in sets we have fundamental operations. Those are union, basic operations on sets, union. Second one is intersection. Third one is difference. Third one is difference. So these are the operations on sets. Okay, now let me explain one by one. First operation is what? Union. First operation is union. By seeing that word, what you can remind, what we can remember? Union. Union is strength. Unity is strength. SN. Union means combined. Okay, union means what? One group. Suppose there are two families. Okay, those two families combined together, that is unity. Yes or no? Suppose in school, suppose to take one school. In school, the same particular school having different branches. Yes or no? So those all branches having employees na. So those all employees come under in school, same school itself. Means those all employees of that all branches coming together, that is union. Yes or no? So here union means combined. Okay. So here how we can do this operation on sets. Now this symbol, before going to operation, what is the representation of union? Symbol is like this. This is the union symbol. Okay. Now I have example. Let us take one set A. That set A contains some numbers. Suppose I am taking 1, 2, 3, 4. Okay, some numbers it is having. And I am taking one more set B that contains the numbers. Suppose 3, 4, 5, 6, 7. Okay, now here I am going to do the operation, union operation on these both the sets A and B. Okay. Similar way in normal numbers, suppose 2 and 3, we can take means we can do the operation on the two numbers. Like that. In a normally union, in the sense, simply you can compare the addition. Okay. So here same way, here I am taking A union B. A union B. Okay, union operation I am doing on both the sets A and B. Union means what I said, combined together, right? So these numbers in set A and numbers in set B, that both together you can write it in one set. That is A union B. See here, 1, 2, 3, 4 over. Now from this, so continuation only we can write. We should not write common elements two times. Common elements only one time we can write. Here what is common? 3 common, only one time. 4 common, only one time. Next 5, 6, 7. Total numbers you will get. Yes or no? Now this is A union B. Now one more example. Suppose I am taking P. P set having some names. Okay, Raju, Rani, Geeta. Some names, it contains some names. And set Q, also having some names. Suma, Roja, okay, Kavita, this. Now I want to find P union Q. P union Q. Okay. Now continuation. All the names it will come together, right? Raju, Rani, Geeta, comma next to Suma, Roja, Kavita. Okay, these all names combined together, it will give P union Q. Okay, why? Because I am taken the sets P and Q, not A and B. That's what P union Q. Okay, I hope you understand by using these examples. Okay, this is a union operation. Okay, on the sets. Now let us see. In this, once show that, is it true? Once show that A union B is equal to A. Let us see. Suppose I am having set A, having the elements or alphabets A, E, I, O, U. What are these alphabets? Vowels. Okay. Now set B having I, O, U. Okay. Now here see, every element of, means every alphabet of set B contains in set A. Yes or no? I, O, U. Here also I, O, U. Every element of every alphabet of set B contains in set A. Okay. So we can say that B subset of A. B subset of A. Now you can show that I am doing A union B. I am doing A union B. Means combine together those vowels A, E, I, O, U. Okay. Repeated terms we can take only one time. That is the note point, remember. Okay, what are that same alphabets? You can write it only one time. Now, what is A, E, I, O, U? A, E, I, O, U. What is that? That is set A. So A union B is equal to A. We got it now? So we proved this. A union B is equal to set A you will get. Okay? This one important thing remember. Now first operation union is over. Next I am going to explain intersection. Intersection. Second operation, intersection. Before going to this, what is the symbol? Symbol of this is intersection. Reverse. Okay. Union means U. Intersection means reverse of U symbol. Right? Can remember. Now, example. What is the intersection? Okay. Those are the common elements. Here we should take only common elements in the both the sets. Okay. Intersection is a set which contains common elements the both the sets. Common elements of both the sets. Okay. Now here a set contains common elements in the both the sets. In the both the sets. What we will take the set both A and B sets. Both the sets A and B. If you take sets PQ, P and Q. If you take XY, X and Y. Okay? Like that. Now one example. How to do the intersection operation on the sets. Let us take set A. Suppose I am having that elements or numbers any. Just I am taking first numbers. Okay? Here 1, 2, 3, 4, 5, 6. And also B set having numbers 3, 4. Okay. Now, see. Otherwise some more also. One more. Some more also take it. No problem. Okay. Now A intersection B. What I said, intersection means only common elements. So what are the common numbers in these two sets? Common numbers. Here 3 is there. Here 3 is there. 3 is common. Next 4 is common. Still any numbers are there common? No, there are no common numbers other than this 3 and 4. Okay, so 3, 4 are the common numbers in the both the sets A and B. So here intersection means we can consider only common numbers or elements. If you consider elements means that alphabet if you take any. Okay. Now common only we can write. Next, shall I explain one more example for this? I think no need. Why? Because whatever they will give the sets, from the both the sets, just you should take only which are common, whether it is elements or numbers or alphabets or names or flowers names or animals names, any. Okay. Now here A intersection B is over now. Here in this A intersection B, if you write in set builder form, suppose X is there, comma, X belongs to A and X belongs to B. If you take intersection. Okay. Now A union B. A union B set you have set builder form. We can take X belongs to A or X belongs to B. Means that X is any element, whether it is alphabets or numbers, any. X is any element. Union means that element should contains A or B. Any one set if it is there, we can take that number. Okay. But in the intersection case, that whatever we are taking element, that element, it should be contains in the both the sets. X belongs to A and also X belongs to B. Okay, in the both the sets it should be present, then only we can take A intersection B, that element. Okay, these 2 points remember. Okay, now this is about the operation, intersection. Next is difference. Next is difference. Difference means normally we can take different symbol what? Minus, right? Subtract this from that. Okay, take the difference of these two numbers, right? So similar way here, third operation, difference. 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 Different symbol is like minus. Okay, now one example. Suppose set A contains some numbers 10, 12, 15, 16. Okay, some B set contains 12, 15, 17, 18. B set contains those numbers. Now A difference B, A minus B. A minus B, what you will get? Just you can subtract number of elements, means whatever you are having elements in B, you can subtract those elements from A. Okay, from A, what are the elements are there in B? 12 is there, 15 is there. Yes, 12 is there, 15 is there. You can remove these remaining numbers, you can write, which are there in the set A, 10, 16. Why we are not taking these numbers? Why? Because these numbers are there in the set B. That's what, those numbers we cannot consider, just remaining. Whatever the numbers are there in the B, that B elements you can subtract from the A elements. Okay, so number set A. So you can don't take, just remaining only you can write, that is A minus B. Okay, A minus B. అంటే Bలో ఉన్న నంబర్స్ని ఏలో నుంచి సబ్ట్రాక్ట్ చేయాలి. మిగతా ఏలో ఏ నంబర్స్ ఉంటే ఆ నంబర్స్ రాయాలి. దట్ ఈస్ ద మీనింగ్. ఓకే, నెక్స్ట్ B minus A. That number of elements means the elements are the numbers which are there in the set A. Which are there in the set A. Now you can subtract from the B. What are there? 12, 15 is there. 12, 15 is there, which are there in the set A. That's what. Remove these two and remaining numbers which are there in the B. First B is there now, you can remember. So from the B set only remaining numbers we should write. From the B set only we can write remaining numbers. Okay. Therefore, from these two, what we can conclude that A minus B is not equal to B minus A. Okay, A minus B is not equal to B minus A. This is the operation, difference operation on the sets. Okay. I hope you understand these operations on the sets. Okay. Okay, thank you for watching and these videos. If you are watching first time, please share this video to your friends, relatives. Okay, and tell them to subscribe and tell them to watch my videos. Thank you. Have a nice day. Bye.